Okay, here's the problem that we were working in class, and I've got the equations. One of them's in black, one's in red, blue, and a green. Before I started running the video, I began to solve this. But anyway, so I solved the green equation first. If you remember, what we're looking for is H loss. So if you're looking for that variable, you try to keep that variable in the equations. Don't ever try to solve for it until the very end. You get rid of all of the other variables first. Okay, so the variables I have, the unknowns is, the H loss. I don't know that. I don't know the velocity. I don't know the, velocity 1, right? So those are the unknowns. So I'm going to try and get rid of those. I do know Q. It was given in the problem. All right, so it doesn't matter what order you take them in, but just remember, leave H loss there. Don't try to solve for it immediately. Okay, so I'm going to start with the green equation, and all I do is I solve for one of the variables, V1. So you can see V1 is this value here. The reason I like to leave it as symbols is because that way I can worry about units at the end and not worry about them all the way through. So anyway, I get the green V1. Then I pick on the blue guy. Notice that the densities can be factored out and divided through, so I get rid of those. And I solve it for another variable, V2. Don't try to solve it for V1. You've already got that one. So you solve for V2. So in blue, V2 is equal to, and I just toss it to the other side, and you get that formula there, A1 V1 over A2. Then I take the green guy and I plug in what I know for V1. So then you get A1 over A2, and then Q over rho A1. The A1s cancel. You see I canceled those in red. Okay, so now I've used the green one, I've used the blue one, so I have formulas for the two velocities. All I'm going to do is I'm going to take those two velocities and I'm going to put them into the top equation. So here we go. In the top equation, I would have minus H loss equals, and this would be alpha. Alpha is known, right? V2 is equal to Q over A2 rho. So that's V2 squared divided by 2G. So that's the first term. Plus P2 over rho G minus, and then, so this would be the alpha over 2G. And I have V1. V1 is equal to Q over rho A1, and that's V squared. And then this negative goes with the pressure inside, so that'd be a minus P1 over rho G. Okay, so now I have an equation. The only thing that's unknown in there is the H loss. Everything else is known. So now I'm going to just gather these terms up. So what I'll do is I'll multiply through by negative. So H loss is equal to alpha negative alpha over 2G. And then I've got a Q over rho A2 squared. And then I have a minus. I'm going to take out that next Q. So minus is plus alpha over 2G Q over rho A1 squared. And now I have the pressures. Okay, so this would be, and I'm going to flip the signs of both of them. So I have plus. There's they both have 1 over rho G, and this would be P1, because I'm flipping the signs, remember, right? Maybe I should show that. So I'm going to multiply through by a negative there. So this term becomes a negative. This one becomes a negative. This one is a positive. This one's a positive, right? Okay, so now that's easier to keep track of, I think. So you have 1 over rho G, P1 minus P2. Whoops, change the color. Minus P2. Okay, I'm going to pause so I can plug in. Okay, so all right, let's see where. Okay, so now all I'm going to do is try to plug into these things here, and maybe I'll simplify it a little bit more before I pull out my calculator. I'll take these two terms, rho over 2g. It'll be q squared times over rho squared, and I'm left with 1 over a2 squared negative plus 1 over a1 squared. All right, so that I think it'd be a little easier. Plus 1 over rho g, p1 minus p2. All right. Okay, so areas. Area 1 is equal to, let's see, they give me the diameters in centimeters. Okay, so I'm going to put everything in meters. So the area 1 would be 1/4 pi times the diameter squared. The diameter is 15 centimeters, so that'd be 0.15 meters. Area 2 is equal to 1/4 pi times the diameter 8 centimeters, 0.08 meters squared. Okay, here's what I'm going to do. I'm going to pause the video, and then I'm just going to pull out the calculator and calculate these values and plug them back in.